Hi, my name is Gayatri, and this is my Lab 5 on magnets. It is a known phenomenon that when a strong magnet is dropped down a tube of metal that's conductive, like copper, it will slow down the magnet. This is because when you drop the magnet down, it will cause a constantly changing magnetic field, which will then induce an electric field in the metal tube, which in turn will create another magnetic field from the metal. This magnetic field opposes the one from the magnet, due to Lenz's law. This will slow down the magnet. However, once this happens, the produced electric field will become weaker, and thus causes the magnet to accelerate again at a point, which, however, would be more evident in a longer tube that allows the magnet to fall for a longer period of time, unlike in this experiment. For this experiment, we are basically using an aluminum foil tube instead of a copper tube due to accessibility. Dropping a relatively strong magnet down the tube should still allow us to see a change in the time taken for it to fall. I will be monitoring this using my phone and then importing it into iMovie to get accurate times for the actual time taken. Using iMovie allows me to get times up to 0.02 seconds. The following video shows the outcome of my glow script code. This slide shows the results from both my experiment and the code. As you can see, the time taken based on the program is lower than the time taken that I measured. This is most likely due to the fact that friction is present when I drop the magnet down the tube, as I am unable to ensure that it is centered right down the middle of the tube and does not touch the sides. If the resistivity of the conductor was to get as close as possible to zero, this would create a very big electrical field due to the fact that the resistance allows greater electrical conduction. This larger electric field will then create, again, a larger magnetic field, which will then counter the magnet further. This will cause the force that the induced magnetic field has to be greater than the magnetic field of the magnet itself. This could result in either the magnet to stop moving or for the magnet to start moving in the opposite direction. However, this will then change the direction of the electric field, and thus the direction of the magnetic field. If holes or slots were cut into the tube, this basically implies that some of the rings within the tube that we modeled would not be complete rings, and thus would not create an electric field and thus a magnetic field around those specific areas. This will then create no magnetic field at those points, which will cause the magnet to accelerate at those specific locations and then again decelerate when it creates another interacting magnetic field.